Good morning. We'll be discussing domain and range of a function this morning. And in these concepts, we are going to find the domain of some functions, and likewise we are going to find the range of some functions. But I must tell you that if you are going to know how to find the range of a function, then you must have known how to find the domain of the function. Simply because to get the range of a function, then you need to find the inverse of that function and you find the domain of the inverse. That means we need a concept. We need an idea of what the domain is. So shall we see how to find domain of functions? Now let me tell you, if we are going to be finding the domain of linear functions, for example, if I am asked to find the domain of functions such as 2x minus 3 now, for example, the domain of this function here is a very simple one. So the domain of the function in question are all values of x that will not make this function undefined or complex. And as you can see here, the function can never be undefined, neither can it be complex. So that means the domain of this function is all set of real numbers, all real numbers generally. That's from negative infinity to positive infinity. That's for a linear function. So what if we are asked to find the domain of a quadratic functions? For example, x squared plus 2x minus 3. How do we get to find the domain of functions such as this? Very simple. The same idea. The values of x that will not make the function undefined or complex. So in this context now, I don't believe we can get an undefined expression. Rather, can we get a value that will actually make this function undefined? That means we can't get complex, neither can we get undefined. That means the domain of this function here, the domain of the function is going to be set of real numbers. That's from negative infinity to positive infinity in one sense. What if we have a polynomial function such as x cubed plus 3x squared minus x plus 1? Yes, the same idea. The domain of the function, values of x that will not make the function undefined or complex. Yes, I've been mentioning undefined. How do you get to know if a number is undefined? A number expressed in the form a over o, you understand, a over 0, you understand now, is said to be undefined. For example, 20 divided by 0 is undefined. 40 divided by 0 is undefined. You understand now? So, and as with the look of things here, we cannot get an undefined expression. Neither can we get complex. A complex number is the square root of any negative number. Square root of minus 2 is a complex number. You understand now? Square root of minus 4 is complex. So in this sense, now I don't believe we can get any complex. Neither can we get an undefined expression. So that means the domain of the function in question here will be from negative infinity to positive infinity as well. So let's see some functions, some rational functions, and see how to find their domains. Yes. How can we find the domain of rational functions such as what we have on the board here? Now the domain of functions, of rational functions, for example, 5 over x minus 2. The domain of this function here would be, remember the concept, all values of x that will make this function not defined, that will make the function undefined, and that will not make this function undefined rather, you understand, values of x that will not make the function undefined and complex. So in this context now, I believe we cannot get a complex function here. We cannot get a complex number here. You understand? We can't get something in root form here, negative root form here. So that means, but the function can tend to give you undefined expression. You understand? For example, if you look at it now, the values of x that will not make this function undefined is if you submit this denominator, x minus 2 not equal to 0. You understand? Because the moment you submit this to 0, then the values of x that will submit this to 0 will make this function undefined. Will get you something in the form something over 0. So, and in this context now, equate the denominator not equal to 0, and that's what we are having here, so that x becomes, x is not equal to 2. So the domain of the function becomes, let's draw a number line for this answer. So we have from negative infinity to 2 to positive infinity. Then we have an open circle here. You understand? At this point it is opening. So the domain of the function comes from negative infinity. The only value of x that will make this function undefined is when x is 2. That's what they are telling us here. So for every values of x that is not 2, then the function will not give you undefined, neither can it give you complex. So the domain of the function is from negative infinity to 2, and from 2 to what? Positive infinity. That's the domain of the function there. So shall we find the rest? Let's find the domain of the next function we are having there. 3x minus 8 all over x squared minus 9x plus 20. So the domain of this function here in question would then be what? So shall we find the domain of the function? Remember the saying, the values of x. That means we need to equate our denominator not equal to 0. Because the domain of the function are values that will not make this function undefined. And so you have to factorize this expression you are having here. So by so factorizing, two numbers that you add together, that will give you negative 9. If you multiply them, you have positive 20. You understand now? That's 4 and 5. 4 and 5 gives you 20. You understand? But you have negative 9 here. So that means if you are using minus 4 and minus 5, that's minus 4 and then minus 5 will not give you 0. So that x minus 4 will not give you 0. And x minus 5 will not give you 0. So that x will not give you 4 and x will not give you 5. Since we have had this one here now, so shall we draw a number line for this to obtain our solution? So we are going to have something like this, from negative infinity, 4, 5 to positive infinity. And so in this context now, what do we need to do? So we draw an open circle at this edge. So the domain of the function, let's see if it exists, is going to be from negative infinity to 4. Yes, negative infinity to 4. And from 4 to 5. Are you with me now? And from 5 to positive infinity. That's where the domain of the function lies. Let's see other examples and see how complex the problem is becoming. Now, shall we find the domain of functions we have here? We have f of x is equals to 2x minus 3 all over x squared plus 4. Yes, remember the saying, the domain of the function s squared are values that will not make the function undefined. Remember, this function can never be complex here. So that means let's deal with the undefined concept. S squared plus 4 is not equal to 0, isn't it? So that s squared will not be equal to minus 4. You understand now? And for us to get x, remember in this case now, if you have to get x, x will be a complex function. Because x, the value of x will be a complex number rather. You understand now? And remember that the domain is set of real numbers. You understand now? So the domain of this function now becomes from negative infinity to positive infinity, because there's no value of x. There's no real value of x that will make this function undefined or complex. There's no real value. There is only a complex value that will make the function undefined. And so there's no real value, then the domain takes from negative infinity to positive infinity. Let's consider the next one, which is a f of x is equals to the root of x minus 4. Now, shall we find the domain of this function now? The domain of the function, as you can see here, this function may be complex, the square root of negative numbers. And so, remember, the domain of the function are values of x that will not make the function complex. And in order for us not to get a complex number, then the value of x minus 4 must be greater or equal to 0. Yes, that's the concept. Once you obtain a number that is greater or equal to 0 here, you understand, in the root form, then automatically this value will not give you complex. And so let's obtain the x, so that x would be greater or equal to 4 in that sense. Since x is greater or equal to 4, let's draw a number line for this solution now. We are going to have something like this. Then we are going to have 4, a close range here, a close point, you understand? So to positive infinity, you should know why it is close. All these are from linear inequalities. So the domain of the function now lies a number that is greater or equal to 4. So the domain of the function gives you a close interval from 4 to positive infinity. Did you get the difference now? The interval is close at this edge in the sense that 4 is included. You understand now? 4 is included in the sense that if you insert 4 here, you get root 0, which is 0. So the number is not complex, neither is it undefined. So that means we can be getting a 4. That's why I said it is closed at this edge and open at this edge. You understand now? So we have successfully find the domain of this function here. Shall we find the domain of other functions we have on the board there? So the domain of other function we are having here becomes f of x is the root of s squared plus 3x minus 28. So what will be the domain of this function? The domain of this function becomes s squared plus 3x minus 28 is greater or equal to 0. Yes, the values of x that will not make the function complex, that will not make you get something in the form of root of negative numbers, square root of negative numbers. And so in this case, what do we need to do? Just insert, solve the problem quadratically, factorize. By so factorizing, two numbers that if I add together, I'll get 3. If I multiply, I'll get 28. 7 and 4, isn't it? Plus 7 and minus 4 gives me 3. Plus 7 times minus 4 gives me minus 28. And so if I decide to insert that, I say plus 7 and minus 4. And so acting on this very thing we have here, so that x will be minus 7 and x will be 4. Yes, let's see which of them attains or satisfies that function here. We are taking from negative infinity to 7, minus 7, and from 4 to positive, from minus 7 to 4, and from 4 to positive infinity. Let's see which one satisfies my function here. You understand now? Anytime you are having something in the form of something, some answers in this format here, then you have to test run which value satisfy this function here. You understand? In the sense that I am having this now. So which of them satisfies my function? I'm picking a number between this range now. You understand? Let's say minus 8. If you insert minus 8 in this place now, insert minus 8 here and see what happens. Minus 8 plus 7 is minus 1, negative. Minus 8 minus 4 is also negative. Negative, negative gives you a positive answer, isn't it? That means the value exists here, because the answer will be greater or equal to 0 in that sense. Since you're having plus something times plus something, then the value is going to exceed 0. You understand now? That means a domain exists at this edge. You understand? Let's see if a domain exists at this edge. Number between this range, between range minus 7 to 4. Let's pick minus 5 for example. Insert minus 5 in this range and see if it satisfies our inequality. Minus 5 plus 7 is 2, a positive number. Minus 5 minus this is negative. Positive times negative gives you what? Negative. So the domain, a domain does not exist at this edge, because if you insert every number within this range, it will always give you negative. And remember, we must get an answer that is either greater or equal to 0. And since we are not getting a number greater or equal to 0 at this range, automatically the domain does not exist at this range, at this point here. So let's see if the domain exists at this point now. Let's insert a number between 4 and infinity. Let's insert 5 for example. 5 plus 4, a positive answer. 5 minus 4, positive. Positive, positive give us a number that is greater or equal to 0. That means we can have the domain existing at this edge too. You understand now? So shall we then give a range of values for the domain? So the domain of the function now becomes from negative infinity to minus 7. You understand now? From negative infinity to minus 7. Yes, it is close at this edge. Remember, it is close. So you must have a close interval union, a close 4. You understand? Telling you it's starting from 4 here to what? Positive infinity. So that is the domain of this function now. So understanding the domain of the function, let's treat the next example. F of x is equal to 2x minus 7 over x plus 3. Now shall we find the domain of the function? So the domain of this function will be very simple. Just equate this one to 0. It's not equal to 0, abi? Because you can't have, okay, this is square root of. So since it is square root of, it's going to take a different approach. Remember, so looking at this one, you will realize that all these ones I have been doing, I'm saying greater than or equal to 0. Do you know that this one could give us an undefined answer? So in order for you not to have, remember the domain for a subset of real numbers that will make this function not undefined nor complex. So in order for us not to obtain that, then the value of x must be a number that is greater than 0. Must be greater than 0 in one sense. So if the value of x must be greater than 0, then x will be greater than minus 3 in that sense. And shall we find the domain? Yes. We have from negative infinity, so we don't need that anyway. We have from negative 3, an open interval, to positive infinity. So in this edge now, what will be my domain? What will be the domain of this function? The domain of the function in question would now be from negative 3 to positive infinity. Yes, they are open. You understand? Because s is a number that is greater than minus 3. You understand? It's not starting from 3 itself. It's not starting from minus 3 rather. So shall we find the domain of other functions we are given here? Shall we find the domain of other functions we are given here? We are given f of x. We are given f of x. F of x root of x minus 4 over s squared minus 25. So shall we find the domain of this function? The domain of the function, at first, let's test run this part here and see what we are going to have. It's going to be x squared, values of x that will not make this function undefined. In order for us not to get an undefined expression, then this denominator must not submit itself to 0. That means we must have x squared minus 25 must not be equal to 0 in one sense. And so that from your concept of difference of two squares, we can have it as s plus 5, x minus 5 must not submit itself to 0, isn't it? So that x plus 5 must not submit itself to 0 and x minus 5 does not submit itself to 0. So that x does not submit itself to 5 minus 5 and x itself does not submit itself to 5. Are you with me now? Now we have been able to do for the denominator. Yes, you can draw a number line for this and show it. This is from negative infinity minus 5, Abby, to 5, and this one is positive infinity. You understand? You can test run. So in this case here, we are having an open interval. You understand now? It is open at this edge. Open. Are you with me? Open. So in this case now, remember there's another function here that we need to treat. You understand now? So we need to treat this as well and see what happens, how they collide, how they correlate. So in treating this one, what do we need to do? Let's see. We need to treat this. So in this case now, remember, in order for us not to get the domain of the function will be real numbers that will not make this function what? That will not make the function complex. So in order for us not to get a complex number here, then we have to have x. Then we have to get a number. We have to get x minus 4. You understand? We have to, in order for us not to get x minus 4 must be greater or equal to 0 in that edge, since you don't want to have a complex and it's a numerator. So that x is greater or equal to 4, isn't it? So that means if we are going to combine these two things together, we are going to be having, let's take from negative infinity minus 5, 4, 5 to positive infinity. And how then do we get the domain? This is open, close. Are you with me now? So how then do we gain the domain of this function? So the domain of the function in question now becomes, since s is a number that is greater or equal to 4, that means this part is not involved already. This will not satisfy the inequality. Likewise, would this one satisfy it? Because the number is from 4 to infinity. So the domain of the function will now be, remember, it is close at this edge from 4 to 5. Are you with me now? And from that 5 to what? From 5 to what? Infinity. Did you get what I have done now? Because the value of x will take from a close interval of 4 to 5 and from 5 to infinity. And that's exactly what we are having here. So if you look at it now, if you pick any number in this range, if you insert it here, they will never give you complex, neither will they give you undefined. You understand now? That's just the concept involved in this one. That's the concept involved. So you must understand the concept involved. Once you understand the concept involved, you are free and the whole thing gets easy for you. So always remember, to get the domain of every function are those numbers, are all those set of real numbers that will make your function not undefined or complex. You understand now? So that means that's what we have been discussing so far. And that is why you must learn to understand what you are doing. So, and that's exactly what we have done here. If we insert a number in this range now, because the value says from s can only appear from 4 to infinity, a number that is greater or equal to 4. And remember, we said there's a limit does not also exist as 5. So 5 is not included also. You understand now? You get union from 5 to infinity. So if you pick any number in that range, you always get a number that is not complex or now let's solve the last problem. That last problem look a little bit tricky. That means you need to understand it before approaching it. So in order to solve that problem, f of x is equals to the root of x, square root of x plus 3 over square root of x squared minus 16. Yes, we need to treat the numerator and denominator in this case. So let's treat the denominator, for example. S squared, remember the domain of the function here, since it's acting as a denominator here, then the values of x that will make this function, that will not make this function undefined and complex. You understand now? For it not to be undefined and complex, then the number must be greater than 0 in that sense. Because if you get a 0 at this edge, the number will be undefined. The answer will be undefined. And once it's undefined, a domain does not exist at that edge. So s squared minus 16 is greater than 0. So that s, yes, from your difference of 2 squared, x plus 4, x minus 4 must be greater than 0. You understand now? So x plus 4, x minus 4 must be greater than 0. So that x must be greater than, yes, x plus 4 must be greater than 0 and x minus 4 must be greater than 0. So that s must be greater than minus 4 and x must be greater than 4 at this edge here now. We can actually draw a number line for this solution here. Drawing a number line gives us from negative infinity minus 4 to positive infinity. They are both open. You understand now? They are both open at their edges. So since they are open now, let's see if a number exists at this edge. Remember, if you pick any number between this range, for example, let's pick minus 5. Insert it here. Will you get a number that is greater than 0? Minus 5 plus 4 is minus 1. Minus 5, that's negative, abi? Minus 5 minus 4 is another negative answer. You understand? Negative gives you positive. That means for all values within this range, we always give you a positive. Well, you always have your domain in there. You understand now? So looking at this part here, let's see if a domain exists here. If you pick this value, if you pick minus 4, for example, you understand now? The domain does not exist at this edge because it will give you a number that is 0. And since it is 0 and we said it must be greater than, so the domain does not exist at this edge. The domain does not exist at this edge. And look at this. If you pick any number in this range, for example, let's pick 5. 5 plus 4, positive. 5 minus 4, positive. We always give you a number that is greater than 0. That means a domain also exists at this edge. But we have a combined inequality here. There's another one here. Look at it. We are having x. Let's combine it. X plus 3, abi? Yes, must be greater or equal to 0. Since you don't want to obtain complex here. So that x will be greater or equal to minus 3. So in this context now, we are going to have from negative infinity to minus 4. We are going to combine them. Open, then minus 3, which is close. It is close at this edge now. Then from my 4 itself, yes, to what? Infinity. Picking from 4 to infinity. You understand now? So remember, since s is a number that is greater or equal to minus 2, that means the domain cannot exist at this region. You understand now? That also means the domain can also exist at this region. You understand what I'm saying now? Let's see if a domain exists at this region. You understand now? If we insert -3, for example, are we going to get, if you look at this now, if you insert -3, you will have a problem. You will see -3 plus this, that's a negative answer. That's a positive answer rather. Then insert it here, that's negative. Positive, negative will not give you an answer that is greater than 0. Since this one will not give you an answer that is greater than 0, then a domain does not exist at this edge too. You understand? There is no domain at this point. There is no domain here. So that means the domain exists at the point 4 to infinity. Did you get it now? If you insert -3 in this equation, you will get a number that is less than 0, which makes the domain not to exist at this point. You understand? That's why we will not use this. So I believe you now understand the concept of domain of a function. Now let's discuss the range quickly. Now the range, like I told you, the range of a function. Yes. You need your concept, the concept of what we have been taught. So the range of a function, range is equal to, yes, the domain of the inverse. Domain of the inverse. The range of a function of f of x is equal to the domain of the inverse of that function. And that will give you whatever thing you need here. That means anytime we are finding the range of a function, we need to find the inverse of that function, then we find the domain of the inverse. For example, let's look at this problem here. We are given f of x is equals to x plus 2 now. How do we find the range of this function? Very easy. So let's assume y to x squared plus 2. We need to first find the inverse of the function. Are you with me now? By making x the subject of formula. So we are going to have, we can rewrite x squared plus 2 is equals to y. Yes, it's the same thing. We can have it that way too. So that x squared is equals to y minus 2. So in order for me to get x, I will square root both sides, so that my x is equal to the root of y minus 2, which happens to be the inverse of this function now. That's the inverse of my function. Now that I've been able to get the inverse now, shall we then use what we have been taught on domain? Shall we then apply it here? Shall we then find the domain of this function? So the domain of the function will now be what? The domain, remember, from what we have been taught. So the domain of the function are all values of x that will not make the function undefined or complex. Here we can't get an undefined answer, but we can get a complex. In order for us not to get a complex, then my y minus 2 must be greater or equal to 0 in that sense. And so that y must be greater or equal to 2. So that the range of this function would now be, remember it is close at this edge, if you draw a number line for it, from 2 to what? To positive infinity. So that's the domain, that's the range rather of the function in question. If you want to find the range of this, first of all find the inverse. After finding the inverse of the function, then find the domain of that inverse, and that produces you with the range of that function in question. Are you with me now? So remember, don't forget to like, share and subscribe. And don't worry, the questions, I will solve as many questions and communicate them to you. You understand now? And if you have any question to ask, my comment section is free. Please come there, send your message, and I'll be so glad to answer or reply your messages. Thank you. I love you. Don't forget to like, share and subscribe.